Now the ways to write all the different derivatives. So for ordinary difference equations, we've got the ones you already know about from single variable calculus. dy dx equals y prime. We leave off the x usually. And then this one is new probably. So it's y, and then it looks like a power, but it's in parentheses and there's a 1. So the parentheses signify that it's actually derivative, and you're taking one derivative of y. Right, so, and then d squared y dx squared, well, that's y double prime, and then that would be y, and then it has as its superscript parentheses 2 close parentheses. And then for much higher derivatives, you have d to the fifth y over dx to the fifth equals, there are 5 primes here, so y quintuple prime. And here's where this other notation comes in handy, so it's hard to write that many primes out. This is actually a lot of writing all the time, and so you have this parentheses 5 close parentheses, which signifies 5 derivatives on the y function. There is one more way that you might see or have seen, so it's common in physics and engineering, and it has to do specifically with functions of time. So we have u of t here, and so you have du dt equals u with a dot on top, and it's pronounced u dot. And then you have d squared u dt squared equals u double dot, and these are used exclusively for time, and because first derivatives and second derivatives occur in physics and engineering a lot in equations, force equals mass times acceleration, they show up a lot. U triple dot would be pretty rare, but you might see this as well. So that's ODEs, and then for PDEs, we have a unknown function f of x comma y, and it uses partial differential equations, take partial derivatives, and so the partial symbol, I tried to draw it well here, it kind of looks like a backwards 6. So the notation for that was you have partial, instead of df dx, it's partial f partial x, and then equals, you can have an f with a little subscript x in front. There's partial squared f partial x squared, well, that's equal to f sub xx. There's partial f partial y, because there are, this is a function of 2 independent variables, x and y, and that's equal to f sub y, subscript y. Then partial squared f partial y squared equals f sub yy. And then because there's more than one type of partial derivative to take, you can actually mix them. So this is partial partial y, partial partial x being applied to f of x comma y. So kind of the term closest to it gets applied first to f. Then after you're done there, then this partial partial y gets applied to whatever pops out. And you can also write that as partial squared f partial y partial x, keeping in mind, try to keep the same order. Then in here, you can do f sub x y, and notice the order did change, so that can be confusing sometimes. But right, the x is closer to the f, so that's being done first, and then y is done second. Then similarly, right, instead of partial partial y partial partial x, we could have partial partial x partial partial y applied to the f of x comma y function. Well, that's partial squared f partial x partial y, which is equal to f sub y x.